Welcome back to another one of my learning implicit differentiation videos where I'll be showing you how to implicitly derive trig functions or equations that have trigonometric functions throughout. Anyway, so let's get started right onto it. So we have our first example, x squared multiplied by y squared plus x multiplied by sine y equals 4. Keep in mind I'm not going to be teaching all these derivatives techniques. I'm going to be explaining them a little bit, but this isn't a video on teaching you derivatives. It's teaching you on how to implicitly derive or implicit differentiation. Anyway, so derive both sides. X squared multiplied by y squared plus x multiplied by sine of y equals the derivative of 4. Okay, this isn't going to be as slow as the previous videos. I'm just going to start picking it up a bit quicker. So instead of writing out the derivative of that separately plus the derivative of that, I'm just going to save room and say this, we're going to call this u, we're going to call this v, and so the derivative would be u dash v plus u v dash, and then we're going to call this one a, and we're going to call this one b. So we're going to add the derivative of a multiplied by b plus a multiplied by the derivative of b, and that equals the derivative of 4 is 0. So let's begin. Okay, u is x squared. The derivative of u is 2x multiplied by dx over dx, which is, because we get the brackets and we find the derivative of the outside, which is 2x, and the derivative of the inside. So the derivative of x with respect to x is 1, but we just write that step anyway, multiplied by v, which is y squared, plus u, which is x squared, multiplied by the derivative of v. Same step, the derivative of y squared is 2y, then we multiply by the derivative of the inside, which is dy dx, which is the derivative. Now we add derivative of a, which derivative of x with respect to x, it's just 1, but still. Then we multiply that onto b, which is sine of y. Then we add a multiplied by the derivative of b. Now the derivative of sine y, use the chain rule. Derivative of the outside of sine is cosine. Leave the inside the same. I'm going to run out of room. Multiplied by the derivative of the inside, so that's dy dx. And that will all equal 0. Okay? Now, I'll get to the fact that we have 2 dy dx is throughout, but first we're just going to simplify this to make some room. So we've got 2x times 1 times y squared plus x squared multiplied by 2y dy dx. You could write that as 2x squared times y. I'm not doing anything tricky, it's still x squared multiplied by 2 multiplied by y, so I can rearrange it however I like, as long as they're multiplied together. And then I'm going to multiply dy and dx, I'm going to separate that. Plus, it's just going to be sine y, because 1 multiplied by sine y is sine y, plus x cos y multiplied by dy dx equals 0. Okay, now we've got to the point where we can start rearranging and start looking for the derivative. Okay, so what I'm going to do is bring these dy dx multiples onto the other side. So I'm going to subtract these from either side. And we're going to be left with 2xy squared plus sine of y equals 2 2x squared multiplied by y multiplied by dy dx. Minus, it's going to be negative because I subtracted it. And then it's going to be another negative because I'm subtracting this to the other side. Cos y dy dx. Okay? So we have what we want on either side. We have the non-dy dx's on this side and the dy dx's on this side. Okay. Now, you notice that we have a dy dx multiplied to this, and then a dy dx multiplied to this. And there's also a negative on either side. What I'm going to do is I'm going to factor out the negative and the dy dx. So I'm going to have negative dy dx, bracket, 2x squared multiplied by y plus x cos y. Basically, if I were to multiply this in to each of these, expand the brackets, I would get this top line. Okay. Now, what we're going to do, this stays the same. I'm not going to rewrite that. But we have 2xy squared plus sine y on this side. What I'm going to do is divide this, because this is multiplied to that. Therefore, we can divide it on both sides, and we'll get it on this side. So we'll have negative dy dx equals this over 2x squared y plus x cos of y. So what I did was just divided this by both sides, which cancels out on this side and leaves it on this side. Now, I'm going to rewrite this over here. Dy dx equals 2xy squared plus sine of y over 2x squared y plus x cos y. Now, where am I going to put the negative? Well, I don't want this to be a negative. I want this to be a positive. Right now it's a negative. So to make this positive, I need to make it a negative on the other side. Okay? So this whole fraction is a negative. But basically, I've isolated dy dx, and here is the function, or the derivative. So I can find the slope at any point on whatever this will graph. Okay? So that is implicitly derived. Now I will do a second example, which will have tan x minus y equals y on 1 plus x squared. Okay, just like before, we're going to derive each side. Okay, now this side we're just going to use the chain rule, no problem. This side we're going to use the product rule. So we're going to call the top one u and the bottom part v. Not the quotient rule, not the product rule, quotient rule. So first we'll do this side. Tan x minus y. Well, when you do the chain rule, you do the derivative of the outside. Derivative of tan is sec squared. Leave the inside the same. Multiplied by the derivative of the inside. So the derivative of x is just derivative of x on x minus the derivative of y, which is derivative of y on x. Now this side. Okay, quotient rule is just going to be u dash v minus u v dash all over v squared. Okay, I'm going to fill this in on the second line. But here, now what you're going to, because we have a dy dx here, and this is technically factored out of this, we have to expand the brackets by multiplying it back into each of these values, because we need this on its own. We can't do that in the state that it is right now. So we multiply sec squared of x minus y onto dx over dx, and then onto negative dy and dx. That will look something like this. Well, dx on dx is equal to 1. Okay, so we're just going to leave it as is. We're going to have sec squared x minus 1 multiplied by 1, which stays the same, minus sec squared x minus y multiplied by dy dx. Okay, so I've multiplied it onto 1 and then I've multiplied it onto dy dx as shown. Now we have this, it's with something, but we have it isolated. We can do something with this now. But now this side we're going to deal with. So the derivative of u, derivative of y is just dy on dx multiplied by v, 1 plus x squared minus u, which is y, multiplied by the derivative of v. Now the derivative of 1 is 0 plus x squared, the derivative of x squared is 2x multiplied by the inside, which is dx over dx. Okay, all over v squared, that is 1 plus x squared to the power of 2. Now we've got a bit. So what are we going to do now? Well, we want to get this dy dx isolated. So what I'm going to do is I'm going to multiply this 1 plus x squared to the power of 2 onto this side, which will essentially multiply it to this value and this value. Now this is going to get a little bit long, but we're going to have 1 plus x squared to the power of 2 sec squared x minus 1 minus 1 plus x squared all squared multiplied by sec squared x minus y multiplied by dy dx. Okay, all I'm doing is multiplying this onto this value and this value to get rid of it on the bottom here. Now what I'm going to do here is I'm going to expand the brackets out here. So dy over dx multiplied by 1 is just dy dx plus dy and dx on x squared, which is just dy dx multiplied by x squared, minus, because I can't fit this in, this y multiplied by that. All that's going to do is just look like 2xy multiplied by 1, because dx on dx is 1. So it's just going to be 2xy. Okay, now we're moving. Now that we've got this right here is great, because now we can rearrange and chop and change for that. We've rearranged and chop and changed to get to this stage, but now we're at this stage where everything, the only thing we got to worry about is the minus and the plus, maybe a divide here and there to get the derivative. Okay. So what's the next step? Well, we got to get all the dy dx's multiples on one side and all the others on the other. So this is multiplied by dy dx, so this stays 1 plus x squared all squared sec squared x minus y, and this is the only thing left that isn't multiplied by dy dx, and we bring it over, which will turn that negative into a positive, 2xy, which will equal, we're going to bring this one over because this is multiplied by dy dx, and because it's a negative on this side, if we bring it over, we'll make it a positive. So it'll be 1 plus x squared all squared sec squared x minus y multiplied by dy dx plus x squared multiplied by dy dx plus just your dy dx. Now this gets a bit long, but this is what you have to do. Okay, now I'm not going to bother writing this side out, I'm just going to use these quotation marks. Now that will equal, we have a dy dx multiplied to this, a dy dx multiplied to x squared, and a dy dx multiplied to, well, it's multiplied to 1 because it's there. So what we're going to do is factor all that out. And we're going to have dy dx on its own, and then we're going to have inside 1 plus x squared squared sec squared x minus y plus x squared plus 1. So therefore, if we expanded this brackets, we would get this mess. Okay, now we have this. This is on this side. What we're going to do to get dy dx on its own is divide both sides by this value, which will essentially bring it under this value. Therefore, dy dx equals 1 plus x squared squared sec squared x minus 1 plus 2xy all over 1 plus x squared squared sec squared x minus y plus x squared plus 1. And that there is the final answer. Now, thanks for watching. I hope you learnt something, and I hope you have a good day.